midpoints are a segment that divides a segment into two equal pieces, and a segment bisector is any line, ray, or segment that intersects some other segment at its midpoint. So a segment bisector divides is a line or a ray or something that divides something else into two equal pieces. The two equal pieces is the important part here. Is that knowing that it gives us a lot of nice information. In particular, if we look at this diagram, the figure shows that this gate, this exterior gate here, has two diagonal braces, MO and PN, or NP. We also know another fact, that MO and NP bisect each other. What does that mean? What does that information tell us about the picture in particular? Knowing that they bisect. Okay.
It's exactly halfway.
What's exactly halfway?
A and Q is exactly halfway between P and N.
Okay, we know that PQ, P and N, PQ is exactly half of the whole thing. In particular, they intersect each other at the midpoint. Yep, so that means Q has to be the midpoint of each of those. And if Q is the midpoint of each of those, what more does that tell us?
It's in the center of the gate.
It's in the center of the gate. And about the segments themselves, what does that mean? If Q is our midpoint, what does that tell us about all the pieces that are being made?
That, like, NP is a segment bisector, and so is MO. They're like each other.
For each other, yes.
Yeah.
So then, what does it tell? I'm trying to drive home. What does this tell us about each of the four smaller pieces that have been made? How do those things relate to each other? Okay.
They're all equal.
That in any one segment they're the same. Not necessarily that this segment's equal to this one. We don't know that fact yet. But we do know that this segment and this segment have to be the same. And that segment and that segment have to be the same. That's what's so nice about segment bisectors. So knowing that, if PQ, if we know that this one has to be 22.6, then what's the length of PN?
45.2.
45.2. If we know that PQ, or half of the whole thing, is 22.6, how do we get the entire length? Just double it. Means that PN has to be equal to twice of whatever PQ is, or PN is equal to twice of 22.6, which is exactly a length of 45.2 inches. Okay. In words and on your own, please write down a description of how MQ is related to MO and how MQ is related to OQ. In words, just on your note sheet. We'll say, we'll go with the first one. MQ is half the length of MO. And how are MQ and OQ related?
They're the same length.
They're the same length. We do know that since it's the midpoint, that the two segments that are created have to be the same length. Or 5x minus 2 has to be the same as 3x plus 8. And from this equation, you should be able to solve and get what?
23.
Solve. X is 5, and then that's not our final answer because I didn't ask what x is. I know what ST is, and our final answer was the length of segment ST is 23. as a check to your work, you could plug this into RS and make sure you get the same length. And in fact, you do get 23 as well. All right, I'm going to erase this as well. For each of these, we're going to assume we have 2 points somewhere in a plane. We'll assume that we have, say, point A is somewhere. And we're going to label point A this way. We don't care what x and y are, but we know that they have to be one's an x and one's a y. So I'm going to call the first x-coordinate x1. And I'm going to call the first y-coordinate.
Is this the midpoint?
This is set up for them, both of these two formulas. It's notation. I'm going to use x1 and y1. And I'm going to use something else. I'm going to use, for a second point somewhere, I'm going to say the second point is the second x and the second y. I'm going to use these two, x1s and y1s and x2s and y2s in the formula. Okay? All these represent is whatever the first x is and whatever the first y is in a point. Whatever the second x and whatever the second y is a point. Okay? For example, if I want to find the midpoint between, say, 1, 3 and -4, 11 or so. I'm going to find between two actual points. The midpoint. The midpoint between 2 points is the average of the x values and the average of the y's. So I'm going to figure out what the average of my x values are and the average of what my y values are. As a formula, it looks like this. The midpoint is exactly the average of the x's. So I'm going to add up the two x's that I have. x1 plus x2. And divide by what?
Y1.
I'm going to find the average of those two x's. So what am I going to divide by? The number of x's, and how many x's are there? 2. I'm going to find also the y-coordinate is the average of the y's. So I'm going to add together the y-coordinates and divide by how many there are. In particular, there's 2 of them. Okay. If we're not used to this notation yet, what we can do is to make it easier to plug in the formula. Let's pick one of the points to be our first point. We'll say G is the first point. So that means this has to be our first x, and this has to be our first y. If h is the second point, then this has to be the second x, and this has to be the second y. From here, it's just plug and chug. I'll plug in the x1, y1, x2, y2s, and then simplify this. So 7 plus -5 is 2. 2 over 2 is 1. -2 plus -6, -8, -8 divided by 2, -4. So this says that the midpoint between 7, -2 and -5, -6 is exactly 1, -4. Is the distance formula. The distance formula you may remember from a while back. The distance formula comes from the Pythagorean theorem. If you remember Pythagoras and his theorem, a squared plus b squared equals c squared. It comes directly from that. And what it says is that the distance between 2 points is equal to the following. It's equal to the difference of the two x values squared plus the difference of the two y values squared, and we'll find the square root of that entire thing. I'll show you next time. Next time I'll talk about exactly where this thing comes from, like how we could actually figure this formula out from Pythagorean theorem, but it says just that. It says that the distance between any 2 points is given by this formula. Now what's nice is that, what did we see earlier this week? What did we see earlier when we looked at standard deviation? If you square a number, what kind of number does it have to be?
Positive.
Positive. Whether it's negative or positive to start with, if you multiply it by itself, it's always positive. So you could, if you want to do x2 minus x1, that works. If you did the first minus the second x, that also works. Because when you square it, you'll end up with a positive number. That'll tell you the distance. Okay?